equal to img as float, img as float, and I will say I am read, and I have my images, and I had got a dinosaur image if you remember, so I'm going to use that dinosaur, S-A-U-R, dinosaur dot png. Okay, this is my image, and I'll take all the information. So only one channel I'm going to use, that is third one. So this is to be specified like this. Okay, and then we are going to decide the threshold, एंड थ्रेशोल्ड हम कह सकते हैं 0.5. पिछले केस में हमने डायरेक्टली अप्लाई कर दिया था, एंड देन वी आर गोइंग टू जस्ट चेक अगेंस्ट द थ्रेशोल्ड एंड विल से बाइनरी में कन्वर्ट करते हैं. सो आई एम सेइंग आई एम इट्स गोइंग टू बी लेस देन और इक्वल टू माय थ्रेशोल्ड. थ्रेशोल्ड का वैल्यू 0.5. पहले केस में हमने डायरेक्टली लिख दिया था, यहाँ पे हमने वेरिएबल क्रिएट करके किया हुआ. ओके, आई एम सेइंग दैट आई एम इज ग्रेटर देन थ्रेशोल्ड. So I'm going to set it 1. So basically you have created your binary image. Then I'm saying skeleton is equal to skeletonize, and I will pass my original image. Okay, so skeleton you have calculated. Now you need to plot. Okay, so I say plot images. हमने हमारा खुद का फंक्शन लिखा हुआ है horizontally. Okay, क्या original image and skeleton image, and name of the operation क्या है, skeleton. Okay, and हम साइज पास कर रहे हैं फिगर का sz equal to say 2:1 ही करते हैं. So 18,9. ये हो गया आपका skeletonization. Okay. This has gone inside the function. Now just see that this was the original figure, and when you are calculating the skeleton will be trying to approximate to the profile of the object. So therefore this is going to be the profile. So that's what you say, the profile is looking like this. Okay, at the legs you can see that the profile is there. So accordingly this is what skeleton is there. So skeletonization में कभी-कभी आपको some artifacts मिलेगा. Say for example, there may be some protrudes like this. Then this can be basically removed with the help of the pruning process. Okay, so ये हो गया आपका skeletonization. You can also apply the techniques for calculating the convex hull also. Okay, so let me say convex hull. So convex hull is nothing but basically the region, okay, which is a convex region which encloses all the given points in the image. Okay, so for that I will use from skimage dot morphology. Okay, I say import convex underscore hull underscore image. Okay, let me see if it is there. Yeah, it is there. So I say I am equal to RGB to gray. I say I am read. I say images slash horse dog. There is an image called as a horse dog dot jpg. Okay, ये एक image है हमारे पास, which we will convert into this, and then we need to binarize that. Okay, so binarize के लिए हम यही वाला use करते हैं. Okay, so we have calculated our binary image, and once the binary image is calculated, we are going to find out the convex hull. Okay, so let me say convex hull. Convex hull is equal to convex underscore hull underscore image, and I will pass this. Okay, so this will calculate the convex hull, and now you can plot this. Plot underscore images underscore hori HORI ZONTA LLY horizontally. क्या original image, and then you have convex hull image. टाइटल आप दे देंगे convex hull, एंड आप साइज स्पेसिफाई कर देते हैं एस जेड इक्वल टू 18,9:1 के उसमें रहते हैं. चलो, and let's say plot this. So this is what your original image is, and now you are going to have the convex hull. So basically the tangent lines are going to be joined with each other. Okay, so this is going to create a convex hull for this. This is a convex hull. So ये जो रीजन ये कॉन्वेक्स पॉलीगॉन है, इसी के अंदर ये पूरा का पूरा ऑब्जेक्ट बैठेगा, उसके बाहर एक भी पिक्सेल्स नहीं होंगे. Okay, so this is what we have done the dilation, erosion, opening, closing, and then convex hull, and then we did the skeletonization. Okay, so you can do that. फिर उसके बाद एक है आपके पास वाइट एंड ब्लैक है ट्रांसफॉर्मेशन. ओके, तो इसे वाइट एंड ब्लैक टॉप हैट्स. For this, we will use from sk image dot morphology import white underscore top hat comma black underscore top hat comma square. Okay, these are the things that we will import. Let me use the Tagore image again. So I'll say I am read. Let me say images slash Tagore dot png. Okay, ये हो गया आपका original image, and I'll use the same convention here, and I'll get only one channel for that, and we will convert that into binary. So हम वही threshold use करते हैं, and we will just convert it into binary. Binary is being converted. Now we will calculate IM1, that is top hat हम calculate कर रहे हैं. So white underscore top hat, and I am saying IM comma SQUAR square of 5. Okay, so आपका जो top hat का structuring element है वो आपका square of 5 है. And then I am saying IM to another transformation that is going to be black hat. I am saying black underscore top hat, and I say original image and SQUAR square of 5. Then you will say pylab dot figure, and figure ka size is size is equal to say 15, आपको जो साइज देना है वो आप दे सकते हैं. Then I say pylab dot subplot, I say 1x2 का 1. ठीक, या तो आप अपने जो अभी फंक्शन लिखे थे वो आप बुला सकते हैं. एक मिनट, होम डिलीट डिलीट pylab dot subplot 1x2 cross का 1 क्या होगा, पहला ओरिजिनल इमेज. आई एम सेइंग प्लॉट अंडरस्कोर इमेज ओरिजिनल. हमारा ओरिजिनल तो नहीं है, दिस इज द white top hat. White top hat. Okay, and then you are going to have the next one, top hat. See here, and I'm saying 2, and this is black top hat. Black top hat. Okay, sorry. Black top hat. And then I can say pylab dot show. Even if you don't write this, still it should run. क्या बात है? I am read. I am read. I am read. So this is your white top hat and this is your black top hat. Okay, so little bit of difference you will find. हमने white top hat लगाया और हमने black top hat लगाया. Not much of difference. 1 cross 2 cross 2. हाँ, तभी तो हमने गलत plot किया था. Yes. I'll see the difference. Okay, so you'll be able to see the difference. Okay, white top hat and black top hat. This is the difference in the white top hat and black top hat. Next, another thing that may be interesting to do, which we have done in class, is basically extracting the boundaries. So you say, sorry. Yeah. So we will extracting boundary. So we are extracting the boundary now, and for that we will use बेसिकली द फॉर्मूला फॉर बाउंड्री एक्सट्रैक्शन इज ओरिजिनल इमेज में से अगर आप इरोडेड इमेज को माइनस कर देते हैं तो यू विल बी गेटिंग द boundary. So that is what we will basically use here. So again, we can use the binary erosion itself. So I say from SK image. Okay, you do not need to load it again and again. In fact, हमने ऊपर already ये सारे functions use कर लिए हैं. Okay, so in that case they are already available. But just for the sake, if you are just going to write it somewhere else, so you should have morphology. Okay, morphology. SK dot image morphology. I say import binary underscore erosion. Binary erosion हो गया. I'm saying I am equal to RGB to gray. हम ले लेते हैं I am read. फिर उसमें से images हम ले लेते हैं. अभी हमने जिसका किया वही करते हैं. Images में से horse dog dot jpg. ये हो गया. And then I will just copy this itself. I say threshold image हो गया आपका बन गया binary. Now I'm saying UNDARY boundary. Boundary is equal to original image minus जो आपका eroded image होगा. तो eroded क्या हो जाएगा? Binary erosion आया. ये हो गया आपका इरोडेड. ओरिजिनल इमेज में से इरोडेड इमेज आपने कर लिया. तो बाय डिफॉल्ट यू आर नॉट स्पेसिफाइंग एनी स्ट्रक्चरिंग डिस्क. सो बाय डिफॉल्ट इट इज गोइंग टू टेक 3 क्रॉस 3 एंड देयरफॉर 1 पिक्सल इज गोइंग टू बी रिमूव्ड एंड देयरफॉर द बाउंड्री जो होगा आपका वर्क्स 1 पिक्सल वाइड आपको मिलेगा. सो आई से प्लॉट अंडरस्कोर images horizontally. Okay, I say image boundary and I say caption is boundary and size is say 18 by 9. ये हो गया आपका boundary. Yeah. Okay, so let's say, yeah, this is what your original image is and this is your boundary of the object. So you are basically eroding this image by 1 pixel, okay, and then subtracting the original image, say eroded image, and that gives you the boundary. Okay, so you can just apply opening and closing on any kind of images and you can just see that what happens. In fact, opening and closing can be applied together. and then combined together. So therefore, opening and closing, you will be basically able to clean your images. Okay, so whether it is a small object or whether it is going to be small holes, they can be removed. One more thing that is there that we can just do is that we can apply it onto the grayscale images. And when you apply the gray on the grayscale images, basically the effect is going to be that you will be highlighting the bright details or you will be basically highlighting the dark details, but at the same time you will want to preserve the counterparts also. Okay, तो general by erosion or dilation जो होता है, so that means they tend to have the removal of the other component also. So you want to retain that. So in that case, opening and closing, binary erosion and dilation, all these things can also be done onto the grayscale images. So we will see that in the next class. Dilation, erosion, or morphology on the grayscale images. Okay, so that is all for now. I have already given the attendance link into your chat box. Okay, so please fill the chat box. And if you just want me to explain anything again, then in that case, just write in the chat box that what you want me to explain once